Most data that we use in population survey data analysis are already saved as Stata Datasets, DTA, or other tabular formats including Excel, database format, DBF, or comma-separated variables, CSV. Before opening any dataset in Stata, be sure to save it in a logical place on your computer, for example, with your project files in a folder called Data. Do not open data from your Downloads folder or desktop. It leads to confusion later on. Before I move on, you can follow along with this video by pausing or repeating sections. To open a Stata dataset using the menus, go to File, Open, then browse to the folder location of the dataset. Alternatively, you can type use folder path name /dataset.dta in the command line or do file. By adding "clear" to the end of the command, you can clear any dataset that is currently open in a Stata session. Stata can only have one dataset open at a time, and it will not open a new dataset without permission to close the previous dataset. To open an Excel dataset using the menus, go to File, Import, Excel Spreadsheet. A window appears. Browse to the file location, select the dataset, and select the worksheet. The equivalent command to open an Excel dataset is import Excel using quotes folder path name /dataset.xls end quote. To specify that the first row of the dataset contains column headers, add comma first row. The menu approach to opening a CSV file is File, Import, Text Data. In the command line or do file, type import delimited using quote folder path name /dataset.csv end quote. To specify that the first row contains column headers, add comma var name parentheses 1, where 1 refers to the row number in the dataset that contains the variable names. Saving a dataset using the menus is as easy as selecting File, Save, and giving the dataset a name. The Save command is equally easy. Type save, quote, folder path name /dataset, end quote. If you will be editing the dataset, which often happens, add comma replace to the command so that Stata updates the dataset with your edits. To browse the entire raw dataset, simply type browse into the command line. You can also browse select variables by typing the variable names after the browse statement. This code, for example, opens a window with a reduced dataset displaying only age, weight, and height. I am going to open the 2010 Demographic and Health Survey KID recode file, which is a very large dataset, to demonstrate the next commands. When we open the dataset, the Data section in the Properties window tells us there are 1,021 variables and 9,002 observations in this dataset. When I scroll through the variable list to the variables window, I find an overwhelming amount of useful-looking data. Browsing the raw data is even more overwhelming. And when I use the describe command to describe the dataset, it tells me the number of variables and observations, which I already knew, and the variable names and labels for all variables in the dataset, which I already have in the variables window. So when is the describe command useful? The describe command is useful when you want to know the variable type and format for a few specific variables so that you can summarize or recode old variables into new variables. For example, I might describe birth variables in this dataset, which all start with the letter B, so I can run the appropriate summary statistics, means for the continuous variables and percentages for the categorical variables. If you are confused about the use of B*, about the use of D instead of describe, or use of the double hash marks, refer to the video and handout titled Stata Tips and Help. In a dataset this large, you will not know all of the variables available for analysis. Manually searching for specific variables, say whether the child received all 3 of their DBT vaccinations, will waste time and make you crazy. Instead, use the look for function and specify any string of text to search the variable labels. If you are looking for DPT vaccination, you could type look for DPT. When we do this, 12 variables with DPT in their labels are shown. Notice how the output of the look for function gives similar information as describe, including the variable storage type. Continuous variables include integer, whole number values like years, long number values, and decimal values. Due to idiosyncrasies with storing decimal values in computers, the demographic and health surveys and other data producers only store integer values by multiplying decimal values by a factor of 10. For example, the sample weight variable, V005, has 6 decimal places, so DHS multiplies it by 1,000,000 to store it as an integer value. To view the distribution of a continuous variable, 2 functions are particularly helpful. The histogram command creates a visual of the distribution of a continuous variable. By default, Stata has an algorithm to decide how many bins or categories to make. For an integer value like year, you might specify the width of a bin as 1 year by adding comma width parentheses 1. The summarize command provides a numerical equivalent to histogram with the mean value, standard deviation, and minimum-maximum values. Categorical variables are best summarized with the tabulate statement. The tabulate, or tab command, produces a percent and count for observations in each category. You can add comma missing, or M, to the tab statement to summarize the percent and count of observations with missing values. Each category and categorical variables typically have a numerical value, like 1, 2, or 3, but are assigned a label like vaccination date on card, reported by mother, or vaccination marked on card. Later, when we start to define our own variables, we will want to know which categorical value is associated with which label. To do this, we can use the label book or label list commands followed by the variable name. You can go to populationsurveyanalysis.com for a PDF version of this video and other learning materials that support your analysis of a population survey dataset.